In today's lesson, we will be practicing the quadratic formula. As you recall, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that over 2a. We use the quadratic formula to find the solutions of the graph of the quadratic equations. Solutions are also known as the zeros, the roots, or the x-intercept. So anytime we're talking about solutions, we're just talking about the x-intercepts where they cross, the parabola crosses that x-axis. In order to do this, we must simply just plug in our a, our b, and our c of the quadratic formula. Today we won't be working with actual equations where we have to plug them into the formula. The equations will already be plugged in, and we're just going to be practicing how to simplify the quadratic equation or the quadratic formula once the equation is plugged in. A couple things that we want to go over before we begin is talking about how many solutions you might have. So as you're working with the formula, you know how many solutions to be looking for. As you may recall from previous lessons, anytime you have a negative sign underneath your radical, there will be no solution. So there's no solution. And underneath the radical is the discriminant. So anytime your discriminant is a negative number, that means no solution. You cannot have a negative underneath in a radical. So here's an example. This negative 3 is our discriminant. And so we know, because it's negative 3, that there's no solution. We do not need to work any further. When it's a negative number, we just write no solution. If the number under the radical is a 0, then we know there will be only one answer. So here is a quadratic equation that has been simplified in the formula. And we have a 0 underneath the radical. So the discriminant is a 0. And when we go to simplify that, because the square root of 0 is just 0, then the answer just becomes negative 2 plus 0 and negative 2 minus 0, which both of those will equal negative 2. And as a result, have a solution of negative 1, and that's the only solution. If the number underneath the radical is not 0, and it's not a negative number, then that means we're going to have two answers. And there's two different kinds of answers that we could have when we have a radical or when we're using the quadratic formula. First of all, if the number underneath the radical or the discriminant is a perfect square, then we know there's going to be two answers. And both of those answers are going to be rational numbers. And when we say they're rational, that means there's no radical in their answer. Here's an example. This particular equation or expression has been simplified down to the very end. Everything that underneath the or underneath the square root has been simplified to the far as it can go. And now we have negative 2 plus or minus the square root of 4 over 2. When we take the square root of 4, we're going to get 2. So we have negative 2 plus or minus 2 over 2. And that can be broken up into two separate equations. The first equation will be negative 2 plus 2 over 2 equals 0, and negative 2 minus 2 over 2. So the first solution we get is 0, and the second solution we get is 2. So we have a total of two solutions. This is very helpful while we're working, so we know how many solutions we need to be looking for. In this second example, we're also going to get two solutions, but here underneath the radical is not a perfect square. And the number is, of course, greater than 1. So that would give us two solutions. This one's a little bit different, though, because we have two solutions, or because the number is not a perfect square, we do not need to work it out. On some of the problems you're going to do throughout this unit, you may be approximating that square root. But for these initial problems, you're just going to leave it just like this. So once I get down to this very basic expression, after all of the things have been simplified, all the parts, and I see that underneath that radical I have a number that's not a perfect square, then I know I can just leave it at that point. Now we're going to begin simplifying this. We're just going to take it in little bits and pieces. So the first problem that we are going to have is that all of the numbers have been multiplied together, and we're down with just the very basics of the formula. I'm not giving you any equations in this lesson to actually plug in. It's just a matter of getting used to solving the parts of the formula here. So I'm down to the minimum, and I need to now look at my square root or my radical, and I'm look inside my radical and I have a negative number. I know that I cannot have a negative number in my radical, so there's no work that I have to do. I just write no solution. In my B problem, I have a 0 underneath my radical. So I do need to simplify this expression a little bit further, but I know I'm going to have one solution, only one. So I just go ahead and work that out, and I will have 4 plus 0 over 2. The square root of 0 is 0. 4 plus 0 will be 4 divided by 2. 4 divided by 2 is 2. On my C problem, I look at my radical and I do have a perfect square. Because I have a perfect square, I know I'm going to come up with two different answers. So I'm going to break this problem up into two problems. The first one will be 4 plus the square root of 36, which is 6, over 2. 4 plus the square root of 6 is going to be 10. I'm sorry, 4 plus 6 is 10 over 2. And 10 divided by 2 is 5. My first solution, or my first x-intercept, is 5. And then I will have 4 minus the square root of 36, which is 6, over 2. 4 minus 6 is equal to negative 2 over 2. Negative 2 divided by 2 is negative 1. Here are two more examples. I have 3 plus or minus the square root of 45 over 2. 45 is not a perfect square, so I know I need to come up with two answers because it's not 0 and it's not negative, so I'm going to have two answers. So I'm going to have 3 plus or minus the square root of 45. There's nothing else I can do to this to simplify it, because if inside the radical is not a perfect square, then I'm just going to leave it as it is. In our E problem, we have the same thing. We have 18 underneath the radical, and we don't need to simplify that any further. You maybe later on in the unit, you may be simplifying the radical and taking out the 3, because you know that is 2 times 9, which makes 18, so you can take out a 3. But as of right now, we're just going to pretty much just leave it as it is. So if you have a number underneath your radical that is not a perfect square, then once you get it down to the very basics of the problem, you can just leave it. The next part of the quadratic formula that we're going to practice is simplifying the expression inside the radical. As you recall, in the quadratic formula, we have b squared minus 4ac, also known as the discriminant. Here we have the numbers that have been plugged in, and so we're going to start off with 3 squared, and 3 squared is 9, minus 4 times 3 times negative 1. Negative 4 times negative 3 will be negative 12, times a negative 1 will be positive 12. 9 plus 12 is 21. So we have the square root of 21. Because 21 is not a perfect square, we can leave that just like it is. It's simplified. And then we have negative 10 squared under the radical, and negative 10 squared will be 100, minus 4 times 5 times 3. Negative 4 times 5 is 30, I'm sorry, 40. No, negative 4 times 5 is going to be negative 20, times 3 is negative 60. And then we have the square root of 100 minus 60 is going to be the square root of 40. In these last two problems that we'll be practicing, we have the entire quadratic formula filled in, and so we need to take each part and simplify it before we can get our solutions. So we're going to start off with the numbers that are in the numerator that are outside the radical, and we have negative, negative 8. And negative, negative 8 would make a positive 8, and plus or minus. And then inside the radical, we're going to have negative 8 squared, which will be a positive 64, minus 4 times negative 4 times 1 times 7. Negative 4 times 1 is 4, negative 4, and then times 7 would be a negative 28. And all of that, of course, is going to be over 2 times 1, which is 2. We break this down further, and we're going to have 8 plus or minus. And we have 64 minus 28, and that's going to be at 36 over 2. We do have a perfect square inside our radical, so we can continue to simplify it. We have 8 plus or minus. The square root of 36 is 6. All of that over 2. Now we have 8 plus 6 and 8 minus 6. So we need to break this up into two different problems. So we have 8 plus 6 over 2, and then we're going to have 8 minus 6 over 2. That plus or minus symbol just means that you have to write it twice. So 8 plus 6 is 14 over 2, and 14 over 2 is 7. 8 minus 6 is 2, and 2 over 2 would equal 1. There are two solutions for that particular quadratic equation, and those solutions or x-intercepts are 7 and 1. Example I, we're going to continue to do the same way. We have negative 6 plus or minus the square root. 6 squared will be 36. And then we have negative 4 times negative 2 times negative 5. If we take negative 2 and negative 5, we will get a positive 10 times a negative 4 will be negative 40. And all of that will be over 2 times negative 2, which is a negative 4. I'm going to continue by saying negative 6 plus or minus 36 minus 40 will be a negative 4. All of that will be over negative 4. I have a negative underneath my radical, so I automatically know I can stop working, and my answer will be no solution. Okay? I cannot have a negative underneath my radical. That concludes our practice on using quadratic formula, and you need to continue by doing the assignment. And you're just going to, today is just like the notes where you're just going to simplify the various problems. It's already plugged in for you. And then in the next lesson, we'll actually be plugging in the A, B, and C and solving the equations by using the formula.